Okay, the last example I had in mind for trig integration is when you have products of trig functions. So let's say you have sine 3x and cosine 4x. Okay, so the integral of this, when you have sine and cosine both multiplied together, well, if you knew integration by parts, which we didn't cover yet, you could try it that way, and there is indeed a way to do it that way, but it's not so easy. So even if you knew integration by parts, the better strategy would be to change this into a sum of two trig functions. And the basic idea is this. Think about the sine of 3x plus 4x. Well, sine of a plus b is what? Sine of a cosine of b plus cosine of a sine of b. Right? That's the sine a plus b formula. We ran over it last time, right? Then sine of 3x minus 4x, what would that be? This part is the same. What's the only difference?
Negative.
It would be minus here, right? Okay, from these two identities, I want this. Right? I want this. So what should we do? Yeah?
Can you just cancel?
You just add them. Yeah, you just add them and it will cancel this part. Right? This is plus, that's minus, so that's going to cancel. On the other hand, these are same, so it's going to double. And this one is just the sum, which is sine of 7x plus sine of negative x. And finally, you just have to divide by 2. So here's what you get. You end up with integral of 1/2 of sine of 7x. And then here's a question. Is sine of negative x equal to sine x or equal to negative sine x? Which one is it? Does this minus survive or just goes away? It's minus, right? Because the picture is it's like this, right? So one side is plus and negative x is the opposite sign. Okay? So don't try to memorize the formula because you'll always get confused, okay? Don't think that your memory works that way. Human beings' brains are not built in the way that you memorize letters, because when was letters invented? Not very long time ago, compared to, like, you had to hunt and find food, right? So images are very, very good for us, okay? So images are a lot easier for us to remember than formulas. So always go this way than that, right? So that's why we have pull the 1/2 out. Now let's try to integrate. What's the antiderivative of sine? Negative cosine. Good. It's negative cosine. And I say this over and over again, but it's really important that you don't memorize the integrals. Even if I ask what's the antiderivative of sine, in your mind you should be asking the question. You should rephrase the question as, what's the derivative of cosine? What's the derivative of cosine? It's negative sine. And that's why you know there should be a negative here. Okay? Always go that way. And if you train yourself enough times, that'll be the natural way to think. And that's the only way for you to not get confused, because if you memorize both integral formulas and differentiation formulas, you're bound to confuse yourself. Okay? The only way out is only stick to one. Don't do the other one. Okay? Just stick to derivatives only. All right, so what do I put in front?
1/7?
Yes. Okay? Because of this 7. Okay? All right, and then the antiderivative sign is negative cosine, but that's a positive, so it'll be 1/2 positive cosine. This negative becomes positive because sine integrates to negative cosine. Plus c, don't forget that, and we'll simplify this as negative 1/14 cosine 7x plus 1/2 cosine of x